Okay, so introductions to functions. So the learner will be able to graph ordered pairs in the coordinate plane. You're going to be able to graph functions from ordered pairs. You're going to be able to define your coordinate plane, your axes, your origin, your x-axis, your y-axis, ordered pairs, x-coordinate, y-coordinate, quadrants, input, and output. Okay, so hopefully this should be a little bit of review from last year. If we don't remember, that's okay. That's why we're going over it now. So when we're talking about functions, we're talking about inputting them onto what's called the coordinate plane. And your coordinate plane is formed by the intersection of two perpendicular lines, which we call your axes, which is the plural of axis, right? The point of intersection is called the origin. But that's the plural. Axis is singular. Right? So the point of intersection is called the origin. It's at 0 on each of your number lines. Right? So you have your horizontal number line, you have your vertical number line where they intersect is at 0 for both. The horizontal number line we call the x-axis. And the vertical line is called the y-axis. Good. Okay, so points on the coordinate plane are described using ordered pairs. An ordered pair. Ordered pair consists of an x-coordinate and a y-coordinate and we write it as parentheses x comma y, which do not confuse that for our interval notation of inequalities. Now we're writing it as an ordered pair, so it always is parentheses x comma y. Okay? So points are often named with capital letters. Your axes divide the quadrant or the coordinate into what's called 4 different quadrants. And it's important that you remember where the location of them are. So if you look up here in this diagram, quadrant 1 is up here in the top right. Then you go counterclockwise. Quadrant 2 is in the top left. Quadrant 3, bottom left. Quadrant 4, bottom right. So it goes 1, 2, 3, 4. Okay? If you have a point that lies on any of your axes, it's not in an actual quadrant.
Stop, Charlie.
Sawyer. So now let's quickly think about my actual coordinates and their values, their signs. So if this is my x-axis going in the positive direction, this would be don't do that. This would be your positive 1. This would be a positive 2. This would be a positive 3, 4, 5, and so forth, right? I could go into the negative direction. So this would be negative 1, negative 2, negative 3, negative 4, negative 5, and so forth.
Did we write that?
Yeah, I would write that in. On my sheet, it's blue. Your y-axis is a number line going in the vertical direction with 0 being the middle. So when I go up, it's going to be positive 1, positive 2, positive 3, positive 4, positive 5, and so forth. When I go down, then it's negative 1, negative 2, negative 3, negative 4, negative 5, and so forth. Okay? So in quadrant 1, are my x values positive or negative?
Positive.
And are my y values positive or negative?
Positive.
Positive. So in quadrant 1, your ordered pair will always be positive, comma, positive. In quadrant 2, what's the sign of your x's?
Negative.
Negative, and your y is positive. So my ordered pairs will look like this. There'll be a negative number, comma, a positive number. And down here in quadrant 3, it would be negative, negative, because your x's are negatives and your y's are negative. And in quadrant 4, my x's are positive and my y's are negative. Good. Okay. Questions about any of that? All right, so points that lie on the axis would not be in any quadrants. In this reading math box, it says the x-coordinate tells us how many units to move left or right from the origin, and your y-coordinate tells you how many units to move up or down. Okay, so if I had to graph the point -4, -4, I would start at the origin, and I would go to the left 4 units, because my x is negative, and I would go up 4 units in the y direction. And that's where point T would be. If I had to plot point U, my x is 0, so that means I'm not moving right or left. My y is telling me to go down 5 units, so that's why point U is down here. V, it's telling me to go to the left -2, down -3, so that's where my point V would be. Okay, so let's practice plotting points. Where would point A be if it was at 4, -5?
I can do that.
I would go where? I would go to the right. I would go right 4, and then I would go down 5. So right 4, down 5. Guys, quiet please. Would put your point A down here. Make sure you label it with an A. Point B, -3, -3, so that means I'm going to move to the left 3, down 3. Always start at the origin. So left 3, down 3, put a dot, would be point B. C is +1, so that means I'm going to go to the right 1. And then I have a +4, which means I'm going to go up 4. So again, starting from the origin, right 1, up 4. Label it with a C. Number 4, D, -5. So am I going to go right or left? Left 5. +4 means we're going to go up 4. So left 5, up 4, put a point for D. For E, I'm not going to go right or left. I'm just going to go right away down 5. There's point E. X, where's X going to go? Right 2, and that's it, because I'm not going up or down. There's point X, bless you. And then Y, 0, 0
Origin?
is the origin, right. So that's not going anywhere. Can you plot points correctly?
Stop being a goofball.
All right, so let's go ahead and summarize all of this. So another name for the horizontal line is what? X-axis, good.
I did that.
What is a number pair that, when substituted in the equation, makes the equation true? Ooh, that's a tough one.
Like a X, Y?
Yeah. So a solution is any number pair that, when substituted in the equation, makes the equation true. Like if we remember, we had problems like x + 1 = 3. What was the solution to that? 2. So a solution is a number when you plug it back in, makes a true statement, right? So the same thing applies when we have an ordered pair. So if I have an ordered pair, that means I'll have an x and a y I need to substitute in to make a solution. Number 3, the point at which both the horizontal and vertical axes meet is called the origin. And represented by the ordered pair, x, y, with parentheses around it. Another name for the vertical line is the y-axis. Good. All right, so in quadrant 1, what are the signs? Positive, positive. Quadrant 2, what are my signs?
Negative, positive.
Negative, positive. Oops, I did that in 3. Negative, positive for quadrant 2. Quadrant 3, what are your signs? Negative, negative. And quadrant 4, positive, negative. Perfect. Okay. All right, can we do it in reverse? All right, race, everybody's okay? All right. So which point is represented by the ordered pair of -2, -5? -2, -5 is matching up with H.
Yes.
Okay, guys, quiet, please. So -2, so that means I'm going to move to the left 2, and I'm going to go down 5, plops me at H. All right, what's the ordered pair for point B?
-3, 3.
Perfect. What point is represented by the ordered pair 4? So to the right 4, down -1, puts us at C. What's the ordered pair for S? Perfect. What point is represented by the ordered pair 0, 5? U. What's the ordered pair for M? Good. Nice job. All right, so are we good with coordinate plane?
Yeah.
Are we good with plotting points on the coordinate plane? Good. All right, so now we're going to get into input outputs. So an equation that contains 2 variables can be used as a rule to generate ordered pairs. When you substitute a value for x, you generate a value for y. The value substituted for x is called the input. And the value generated for the y is called the output. So sometimes we think about it as like this function machine, right? If I plug in 1 for x, what's going to be the output?
1, 6, 11.
10 times 1 is 10, plus 5 is 15. If I input 2, what would be the output? 25. If I input 3, what would be the output? If I plug in 0, what would be the output? If I plug in -1, -5. Good. So input goes into the x, and then your y is your output. So in a function, the value y is your output is determined by the value of the input. All of the equations in this lesson will be represented as functions. So here we have a function, y equals 2x minus 7. If I input 2, what would be the output? So 2 times 2 minus 7. So -3, right? Because it would be 4 minus 7. If I input 5 for my x, y would equal 2 times 5 minus 7. So 10 minus 7. So y would equal 3.
Wait, what are we on?
If I plug in -10 for x, so 2 times -10 minus 7 is -20 minus 7. So y would equal -27. What would this look like as an ordered pair? If y equals -27 and x was -10, what would be the ordered pair?
27.
Charlie's got it. -10, comma, -27, right? Because my x was -10. When I input -10, my output was -27. Questions? We're doing okay? All right, next page. So now let's add some words to the mix. So an engraver charges a setup fee of $10 plus $2 for every word engraved. Write a rule for the engraver's fee. Write order pairs for the engraver's fee when there are 5, 10, 15, and 20 words engraved. So here they have it done for us. They're going to let Y represent the engraver's fee, and they're going to let X represent the number of words engraved. right? So we start it with $10 plus $2 for each word. So we have y is equal to 10 plus 2x. So our function rule is y equals 10 plus 2x. That's my function rule, gentlemen. So now I can take that function rule and I can create what's called a table of values, which they have provided for us. So when we input 5, I get 10 plus 10, which is 20, which makes the ordered pair 5, 20. When we input 10, what's my output going to be? 30, which would give me the ordered pair 10, 30. If we input... Okay.
Hold on. You need to cut off.
Hayden, please stop.
Sorry.
Yeah, Hayden, that was great.
If I plug in 15, then my function rule would be y equals 10 plus 2 times 15,
40.
which would be 2 times 15 is 30, plus 10 gets us to 40. So the ordered pair would be 15, 40. And then plugging in 20 would be the same. So y equals 10 plus 2 times 20. So 2 times 20 is 40, plus 10 gets me 50. So the ordered pair would be 20, 50. All right, in your group, see if you can do the next example on your own. Go. With mine, how'd you guys do? So 30, 50, 70, 90. And then you have your ordered pairs.
I would have, I just messed up. I didn't use 20, I used 2.
Oh, yeah. It's 20 because it's $20 per person, which is a little bit different. Okay, so now we're going to bring this all together. Is everybody ready? Okay, so on to the back. So now we are going to do all of this together and then put it onto a graph. So now we know how to make ordered pairs. We know how to graph ordered pairs. Now let's put it onto the actual graph. So here I have a function rule of y equals 2x plus 1. I have my x inputs of -2. So let's plug in -2 over here. -1, 0, 1, and 2. So now let's do the output. So try to write it a little bit small here. So we're going to do 2 times -2 plus 1. What does that equal? Well, 2 times -2 is -4. -4 plus 1 is -3. So what would be my ordered pair? -2, -3. Perfect. Can you plot that point?
Whoa, dude. Gee, these are broken in half right now.
Put it on your plane, coordinate plane over here. So -2 is the left, down 3, -3. There's your dot. Okay, so now let's do the same thing for -1. 2 times -1 plus 1 would be -2 plus 1, which is -1. So then we have -1, -1 as my ordered pair, which means we're going to the left 1, down 1. So that dot's going to be right about there.
Yep, I do.
Let's do the same thing for 0. 2 times 0 plus 1 would be what?
0.
Not 0. It'd be 0 plus 1, which would be 1. So your ordered pair is 0, 1. So plot that point. Do the same thing for 1. So 2 times 1 plus 1 is 3. So my ordered pair is 1, 3. So I'm going to go to the right one, up 3. And then for 2, 2 times 2 is 4 plus 1 is 5. So that ordered pair would be 2, 5. So to the right, 2, up 5. So now, what pattern do we see? So we're asked to describe the pattern.
It's like, go help our group.
Yeah. The slope is
Well, what kind of shape is it making? Is it making a line, a curve?
Like
Making a line.
line.
So it's making a line would be my pattern.
2.
Can't read.
Questions with that one? All right. Let's go to number 2. Same thing. Different rule. So we're using -2, -1, 0, 1, 2. So let's go ahead and put in our inputs and get our outputs. Ooh, squaring something. How do we square something? What's -2 squared? It's +4. -3 would be 1. So -2, 1.
Are you more complicated than it was last year?
Do the same thing for -1. -1 squared is 1. -3 is -2. So my ordered pair is -1, -2. 0 squared is 0. -3 is -3. So then we get 0, -3. What's next? 1 squared is 1, -3 is -2. So then we get 1, -2. And then 2 squared -3 is 4 -3, so 1. So 2, 1. So now when we plot these, -2, so left 2, up 1. -1, -2, left 1, down 2. 0, -3 would just be down -3. 1, -2, right 1, down 2. And then 2, 1, right 2, up 1. Do we have a line anymore?
No, it's a V.
Nope. So we kind of got like a V or a U. So V-like. I think it's probably more U-like than V, but
No, that's okay.
we definitely don't have a straight line.
If you trace that.
If it were a V, so if I drew a line straight through this to make it a V, I would need to have hit those other points.
That's literally a V.
So if I connect it, it's more U, right? Do you see how it's more U than V?
Oh, I mean, I guess, but.
So I would say it's U, like shaped like a U. All right, everybody's got that one down. Do the last one. Ooh, absolute value. Yeah, yeah. So for our absolute value, we've got inputs of 0, 1, 2, 3, 4. Here we go. Let's input it and evaluate. The absolute value of 0 minus 2. What is 0 minus 2? And the absolute value of that is positive 2. So we've got 0, 2. Do it for 1. The absolute value of 1 minus 2 is -1. Absolute value of that is positive 1. So we've got 1, 1. Absolute value of 2 minus 2. It is 0. So we've got 2, 0. Absolute value of 3 minus 2 would be 1. So 3, 1. Absolute value of 4 minus 2 would be 2. So 4, 2. So we just generated 5 ordered pairs that we're now going to plot. 0, 2 means I'm just going to go straight up to 2 on the y-axis. 1, 1, right 1, up 1. 2 zeros just to the right 2. 3, 1, right 3, up 1. And then 4, 2, right 4, up 2. What's your pattern? Yeah, this one's definitely V. So shaped like a V. All right, get out your computers to see how much you got of this.